So this is our final lesson for beginning to be a chemist, and it's our final lesson on acids and alkalis. What we will look at is a process called neutralization, and then there will be a series of questions revising the whole acids and alkalis topic. So neutralization is what we call a reaction, a chemical reaction that happens when an acid is added to an alkali. So when an acid and an alkali mix, acids have a pH less than 7, alkalis have a pH greater than 7. When you mix them together, the overall pH moves towards 7. And the solution, that is the product of that reaction, will be neutral. And that's why the reaction is called neutralization. It's about making acids and alkalis become more neutral. So here we have an acid that's pH 2 plus an alkali that's pH 9. When you mix them together in the right ratio, you can end up with a neutral solution, pH 7, and you would see this reaction happening if you had universal indicator in it. When it turned green, you would know that you had achieved neutralization, that the solution had turned neutral. So if you are able to do this in class, you will be set a task of trying to get neutralization, and you'll find out that it's not actually as easy as it might seem. So you will get a test tube with an acid in it, a test tube with an alkali in it, and an empty test tube. Your task will be to try and mix together the acid and alkali in the middle test tube to try and get it to a green color. So if you are doing this in class and you've seen this slide, you will know that this can take quite a while, and you could go for maybe 10-15 minutes and maybe not able to do it. But that's a challenge you get to do in class. So this is the basis of the experiment. You've got an acid, you've got an alkali, and you are trying to make that green color by neutralizing it. And you have to try and work out how much acid and how much alkali do you need to add in order to get the green color, and you don't want to make it any other color. Now, neutralization reactions happen every day. So bee stings, however, it looks like that's a wasp sting there, and bee and wasp stings contain acid. So if you want to remove the pain of a bee sting or of an ant bite as well, what you would do is you would add an alkali to it. So if you got stung by a wasp and it was really hurting you, if you put toothpaste over the sting, it should help the pain go away quickly, because the alkali in the toothpaste would react with the acid in the sting and turn it into something neutral, and neutral solutions do not cause any pain. Another example is if you eat too quickly or you eat too much and your body produces a lot of acid, that can cause you heartburn. So heartburn has nothing to do with your heart. It's just because your stomach is, believe it or not, located very close to your heart. And if your stomach produces too much acid, you feel a burning sensation in your stomach. And because your stomach is quite close to your heart, it's just below your heart, that's where the term heartburn comes from. There are lots of products out there that are called digestive aids or Alka-Seltzers, or antacids. These are pills that are designed for you to take to get rid of that heartburn sensation. And what they are is alkalis, and they neutralize that excess acid in your stomach, turn it into a neutral solution. And what that does is it really helps to eliminate some of the pain and discomfort that your body feels if it has too much acid in its stomach. So that was a really quick go over of neutralization. And some things to talk about and to think about are, why is it important for us to know the pH of everyday products? And what you might want to do as a task is write down, what do you think the problems can be with having strong acids and alkalis, and how could we maybe use strong acids and alkalis to stop some of these hazards themselves? And you might want to think about how acids and alkalis, when they're put together, can neutralize in that. So good examples are like the wasp or bee sting, where they are caused by acids. So if you add an alkali to it, it can help neutralize it and eliminate the pain. So that was a very brief set of introductions to neutralizations. Now what we're going to do is we're going to go over a set of questions covering the whole acids and alkalis topic. So what we have, first question. So all chemicals can be put into a category according to how, what, or what they are. So as before with these questions, if you want to pause the slideshow to give yourself an opportunity to write down answers, you can, or you can keep the answers in your head and see whether or not you get the right ones. So with this one, all chemicals can be put into a category according to how, what, or what they are. Well, the answer to that is acid or alkali they are. So chemicals are described as being acids or alkalis. So if you were asked what is an acid, there's probably a few different definitions that you could give, but let's see what you can come up with. What is an acid? Well, one definition is an acid is the opposite of an alkali. You could say an acid is a chemical that turns universal indicator red or orange or yellow. Or you could say that an acid is something with a pH less than 7. All of those would be appropriate answers to that question. So this one, what is the missing word? An alkali is something that is the opposite of an alkali is something that is an opposite of an acid. Alkalis and acids are opposites. If something is not an acid and it's not an alkali, what would we call it? If it's not an acid and it's not an alkali, what would we call it? Well, that would be something that's neutral. Okay, so now this is give 2 everyday examples of where you might find acids. So the types of either things that you encounter that contain acids in your everyday life, or acids that you encounter on their own. So just 2, but there are lots more than 2, obviously. So here's some: fruit juice, vinegar, skincare products. You could say your stomach, that's acidic. You might have said wasp stings, those are acidic. Sugar is also acidic. Now, 2 everyday examples of where you find alkalis. So soaps and other cleaning materials, cleaning products, are alkalis. So if toothpaste is also in there as an alkali, bleach, oven cleaner, washing powder, washing up liquid, and then antacids or things used to treat heartburn by neutralizing stomach acid. Next question, well, this one's a bit more specific. So common acids that you might use in the laboratory. There are 3 common acids We're asking you to name two of them if you can remember it. They are quite specific words. And those acids can be very what? So common acids in the lab, and these acids can be very what? Well, sulfuric and hydrochloric acid. Nitric acid would also be in there. And these acids can be very dangerous. Oh, they could also be very harmful. You could say any sort of word related to dangerous. Could be very concentrated as well. Next question is, what do we do if we want to test a substance for how acid or alkali it is? What do we use to test if a substance is acid or alkali? This one, the answer is we use universal indicator. Or if you wanted to, you could have said another type of indicator. Maybe you tried the red cabbage indicator. That would work. But the main one that we're looking for is universal indicator. Next question. What scale is used to compare the color change of universal indicator? What scale do we use? What's the name of that scale? So it is the pH scale. So we have now got a series of strong acid. We've got a strong acid and we've got a neutral solution. What we're looking for is three answers. What color is a strong acid on the pH scale? What color is a strong alkali on the pH scale? And what color is a neutral solution on the pH scale? So what color each one of those? So what we have is an acid is red, an alkali, you could say dark blue or purple, and neutral is green. So the left-hand side of the acid, the middle of the is the neutral one, and the right-hand side is the alkali. So let's see, can you remember what pH would bleach be? What number we're looking for would bleach be? So bleach would be pH 14, but it's a strong alkali, so if you'd written 12, 13 or 14, that would be acceptable. Next one, what pH would vinegar be? Well, vinegar is a weak acid. Well, vinegar is an acid, so it would have a pH of 1 or 2. Probably would accept 3 or 4 as well for vinegar. What pH would water be? What number pH would water be? Well, water is neutral, so water is pH 7. Okay, now we've got a question here. When acid is added to an alkali, so if you add an acid to an alkali, the pH of what is produced when an acid is added to an alkali, does that pH move closer to 14? Does it move closer to pH 7? Or does it move closer to pH 1 whenever you add an acid to an alkali? What does the pH end up? Well, an acid and an alkali together is called neutralization, so it is pH 7. If you add an acid and an alkali together, you make a solution which is what? An acid and an alkali together, you make a solution which is neutral. And what do we call the type of reaction where an acid reacts with an alkali? What's the name of that reaction? That reaction is a neutralization reaction. And our final question is a hot skills question, so that's going to be numeracy based. And so we've got a table there, and we've got solutions A, B, and C, and we've been told that solution A is a pH of 3 and it has a current of 18. Solution B is pH 4 and it has a current of 9. Solution C has a pH of 6 and it has a current of 5. What it's asking you to do is predict what the current would be for a solution with pH 6. So using that information in the table, predict. So the answer, it has to be less than 5 but greater than 0. It looks as if each time the pH goes up by 1, the current seems to drop by about half. So probably 2 or 3 is your best answer, but if you'd said anything less than 5 but greater than 0, you would have got the mark for that. So that is us gone through all the questions related to acids and alkalis, and that is us actually finished all of the topics for chemistry in S1. So thank you for paying attention the whole time and watching all these videos, and well, hopefully see you next time.